Okay, let's take a look at writing the equation in slope-intercept form and then graphing the particular equation on the coordinate plane. So our first example we want to look at is y equals 3x plus 2. And as we examine this carefully, it is already in slope-intercept form, which is y equals mx plus b. So we do not have to reconstruct the equation. We just literally have to look at our first plot, which is 0, 2, and that should be obvious to us because we know that 2 is b, which is the y-intercept, and when we have the y-intercept, x is 0, so that our first order pairs are going to be 0 and 2. So we'll start at the origin and go up 1, 2, and make our first point. Okay, then now we want to use the slope to create our second point, and that's all we need because it just takes 2 points to make a line. But when we look at our slope, which is 3, it does not give us anything but a rise. It does not give us a denominator. So now we have to go back and look at real number rules and understand that when an integer is by itself, its denominator is actually 1. So we can create this as 3 over 1. So starting from the first point, we can go up 3, 1, 2, 3, and over 1, and make our second point. And then the third step is just to literally grow the line. Okay. So what about if we're given an equation in linear standard form? 2y plus 3x is equal to 6. Well, the same steps apply, with the exception that we have to first write this particular equation in slope-intercept form by solving for y. So again, if we're solving for y, we need to understand we need to isolate y by itself. So our first priority is to take 3x and get rid of it from the left side. And remember, when you're working with equations, that whatever you do to the left, you have to do to the right. So we will write here 2y plus 3x minus 3x, and that's subtracted from the left side, is equal to negative 3x plus 6. Okay, excellent. Here 3x minus 3x is just going to give us 2y is equal to a negative 3x plus 6. Okay, y is still not isolated, but we have it down now to a one-step equation. We can see that actually y is being multiplied by 2, so we want to divide every single term by 2, and on the left side, 2 and 2 is going to give us 2 divided, and 2 is going to give us 1. So this would be 3 over 2x plus 3. Okay, so now we have this particular equation in slope-intercept form, and then we're going to go back up to the graph and see can we literally graph this particular equation. So we will look at our y-intercept, and our y-intercept is actually 3. So let's take, and from the origin, and we're going up 3, 1, 2, and this point is going to be here. Okay, great. Now we need to look at our slope, and our slope here is a negative 3. So that means we're going to rise a negative 3, or fall actually. So we start from our point and we're going down 3, 1, 2, 3. That's going to put us back at the origin, and we're going over 2, 1, 2, and we'll put our second diagonal. Okay, now all we need to do for the third and final step is to connect the points. Okay. So, draw a line. And for better or worse, we see our little line is going down and to the right, and that's obvious because we see a negative 3/2, which is going to tell us that we will have a negative slope. So again, when you are graphing or writing into slope intercept form, if you're already there, you're just simply going to plot beginning with your B or your y-intercept. But if not, if it's in standard form, standard linear form, then you need to solve for y, and begin so by bringing your x value on the side with your actual constant.